and the other day we talked about the fact that this number does not follow the number in AP Classroom, and that I'd give those two at the top. I'm not sure that I did that on the last thing that we did, but this is where it is. If you want to, 1.6, 1.7, 1.9, and the topic questions are already assigned to you, but it's only part of 1.7. But again, if you want to go back and rewatch a video or whatever, that's where it belongs. If you don't know that, it's these numbers. It's not the end of the world, but I want you to at least have it. Okie dokie. So we know that the best way to always try to evaluate your limits, if you can, is just by direct substitution. Direct substituting it in. If it works, there you go. If not, that's why we have to have other reasons to do it. And when those things happen, if we get 0 over 0 or infinity over infinity, those are bad things. Well, not bad, but they're indeterminate forms, and they can't be our answers. We never want to write equals infinity ever. Definitely don't want to write equals infinity over infinity or equals 0 over 0. What we do want to do, though, and this is not, we did some left and right type of stuff, but we also want to write, if I have a rational, the fraction, I'm going to write it as the numerator and the denominator. So I'm going to write the limit as x approaches 1/2 of 2x squared plus 5x minus 3, and the limit as x approaches 1/2 of 2x minus 1. And then we just evaluate both of those. So if I take 1/2 and I substitute it in here, what's 1/2 squared? 1/4. I multiply by 2, that gives me 1/2 back, right? Plus 5 times 1/2, we can say plus 5 halves. And then minus 3, but what's 3 in terms of halves? How many halves is 3? 6. So I'm just going to go ahead and write minus 6 halves so we can put it all together. And when I put all that together, what does that give me? 0. So that gives me 0, which does not mean that the limit is 0. If what I put in down here gives me anything other than 0, then my limit is 0, right? If I get 0, that's different. So here, when I substitute this in here, 2 times 1/2 is 1, so I get 1 minus 1, which is 0. So then that means my limit is 0 over 0. Again, I'm never going to put equals 0 over 0. It can't. Since that happens, then I have to do something else. And so in this case, because there's different things that are going to happen, I can factor the numerator. So let's start by the factoring part. Plus, that's exactly what it says right there, factor. Kind of gives it away. So this is equal to the limit as x approaches 1/2. And then I'm going to leave it as a fraction because I want to be able to reduce things. So it's not that I have to do this in order to answer it correctly. So it's fine that I'm not splitting it to factor. There's other reasons we need to do this, which we'll get to, but we're just practicing doing it. Mainly so I don't accidentally at the end right now put 0 equals 0 over 0, because then they won't look at anything else you write. That's like bad. So then we're going to factor. So I know the denominator is still 2x minus 1. So this I can factor by grouping, but let's think smarter, not harder, right? When I substitute in 1/2 into here, I get 0, right? So that I'm thinking one of my factors right here is going to be 2x minus 1. If that's the case, now again, if you have to factor by grouping, it's fine. I just want you to start thinking outside the box a little bit. This will have to be x. This would have, since this is negative, these signs have to be opposite, so it has to be plus. And what does this number have to be? 3. And then double check yourself. Like if you're thinking outside the box and trying to reason through it, then check yourself, okay? So I know this would give me 2x squared. Then this would give me 6x minus x gives me the 5x, and then I get negative 3, okay? So just trying to show you a different way to think. Some of you are going to latch onto those things a whole lot faster. Some of you are going to be like, nope, I'm going off to the side, and I am doing by grouping, and that is totally fine, okay? Just trying to show you some different things. Notice I did not drop this yet. Still can't drop this limit notation. So now I'm going to say this equals, I still have the limit as x approaches 1/2 of, well, this is going to cancel out, right? And that's totally fine to do. I still have not evaluated anything because I still have variables. This is of x plus 3. And then tell me in what you would consider, or you think I would consider an illegal form, what is 1/2 plus 3? And we're not cooking, but it's okay. 7/2, or in this particular case, because it is your final answer, and it makes my skin crawl, but it would be okay to say 3 1/2. Even though I did tell you if we're not cooking, we don't care because we don't need 3 1/2 cups of it. But yes, you were right, 7/2. I appreciate you. But here's the thing. In calculus, remember, there are safe stops. This would be a horrible, like if I was going to actually use this to go forward on anything else, then I would need it as 7/2 or 3.5 because that's just junk. But because the form of our final answer is fine, I hate to say it, but because I'm stopping right here, that would be okay. 7/2 would be fine, 3.5 would be fine, and so forth. We're good? Okay. And 3 1/2 is probably maybe safer than 7/2 for some of you if you wouldn't multiply and add those numbers correctly or have a weird brain fart. Might as well just do it and be safe. Okay? We're good? Okay. But I don't want to see that in the middle of a problem or anything else. That's when it becomes bad and you're just going to make life harder for yourself. So if you're going to end up with 0/0, then you factor and reduce is one option. Let's look at number 2. So we're going to start the same way. We are going to do numerator and denominator. So I'm going to have the limit as x approaches 0 of the square root of x plus 2 minus the square root of 2, and the limit as x approaches 0 of x. So when I substitute 0 into the first one, that would give me the square root of 2 minus the square root of 2. And what does that give me? 0. And then this one just gives me 0. So once again, when I put them back together, I'd end up with 0/0, so I can't put that. All right? Well, not that they're equal. That's a very good question. I wish there was another. Let me see if I can come up with something random to answer, because I do understand that question and why you're asking me. So let's say we have the limit. You don't have to write this down. Just follow me because I think this is a very good question. We'll say as x approaches 1 of x plus 3 over x minus 5. Let's just say that that's our question. Okay. So we would still do the limit as x approaches 1 of x plus 3 and the limit as x approaches 1 of x minus 5, okay? Then we're going to substitute in just like we have. So this is going to give me 4, and this will give me what? -4, okay? So then in the end, since I'm not going to have 0/0, I'm not going to have infinity over infinity, my answer would be 4 over -4, and my answer would be -1, and we wouldn't have to do anything else, okay? So I'm doing it to see if I'm going to get 0/0, and these just happen. I didn't even mean for them to be the same number but different signs. They could be anything. To see if I'm going to get 0/0 or infinity over infinity, because we're going to learn a little bit later down the line a different way to approach this, and you pretty much have to do this part. Okay, that also keeps you from putting 0/0. It's a very, very good question. And had I gotten, just pretend like these numbers were different, or let's pretend like this was -3, -3, right? Okay. Then this would give me 0, and this would give me -8, right? So getting 0 is okay. 0/-8 would just give me 0 in the end. And you can have a limit that's 0, but they wouldn't both be 0 then. Okay, does that help? Thank you, it's a very good question. All right, so let's go back over here then. So right now, I guess you're splitting it, because I'm telling you have to, because it's going to matter a little bit later. But then by splitting it, I could put them back together, but because I'm getting 0/0, that's why I can't, okay? So since this, factoring it, we can't factor that, right? So if you have the square root thing, we multiply by the conjugate. Do y'all remember doing that? It was kind of ugly, but it's not terrible. If you don't remember, it's okay. Or I mean, at least remember like it looks like something we did. Does anybody remember what the conjugate is? Or how I make the conjugate out of this mess in the numerator? And it's, so we're rationalizing it. We didn't have to rationalize the denominator. I'm rationalizing my square roots. Conjugate's actually very simple. If I have x plus 3, my conjugate is x minus 3. That's all it is. So we're going to multiply this. I'm not writing my limit statement because I'm trying to multiply by this part. I will rewrite the limit statement in a minute. I need the conjugate of the numerator. So this is the square root of x plus 2. I don't change what's underneath any square root. But since this was negative right here, this one becomes positive, like that. Okay? And if this was positive, that would be negative, all right? I can't change the value. I have to multiply by a value of 1, so that means my denominator looks like this too. And although it looks yucky, the numerator is still what kind of situation when I multiply them? Difference of squares, right? This is like x minus 2 and then x plus 2. It's a difference of squares. And so if I had x plus 2 times x minus 2, when I multiply it, so now since I have an equal sign, I have to continue my limit statement because I haven't evaluated yet. I'm just working with this stuff in here. The limit is x approaches 0, and then here's my whole big old fraction. So I square, so if it was x plus 2 times x minus 2, that gives me x squared minus 4, right? That's because we squared this first thing. So when I squared this, what do I get? X plus 2, good. And because it's a difference of squares, no matter what order the signs are in, this is always minus. Then we square this, and what do we get? 2, very good. The denominator, we're not going to distribute. We're not going to worry about the weird stuff. We're just going to have this x, and then parentheses, square root of x plus 2 plus the square root of 2. I know that it all looks horrible, but it's really not. We don't have to do anything really weird with this stuff. So what's x plus 2 minus 2? X. So these cancel out, right? And then, so I'm just left with x in the numerator. What happens with the x in the numerator and the x in the denominator? They cancel out. So that means I'm left with the limit as x approaches 0 of 1 over the square root of x plus 2 plus the square root of 2. Everybody good with all that? Ask me a question. We're good? Okay. Looks yucky, but it's doable, right? Now that I have that, and I'm not going to split it again. I made you split it at the beginning, even though I still have a fraction. I'm not going to split it now because since I did what I did, I should not get 0 over 0. And if I do, I did something wrong. Alejandra, ask me a question. You just couldn't read what I was saying. So now when I substitute in 0, now that I'm substituting it in, that's when I drop my limit statement, right? Because our notation is important. And I get 1 over, 0 plus 2, that's going to be the square root of 2 plus the square root of 2. And as far as a free response question goes, this is what we would consider a safe stop. So if we put SS anywhere, that'll mean safe stop. Let me put that. So SS means safe stop. But of course, if it's a multiple choice question, that's probably not one of the answer choices just because, it's just probably not. But what's the square root of 2 plus the square root of 2? 2 square roots of 2, so this gives me 1 over 2 square roots of 2. And then we could rationalize it if we had to. When I rationalize this, we know how to rationalize a denominator, right? Again, wouldn't have to if it was free response, but maybe I need it to match an answer choice. Do I have to multiply by 2 square roots of 2, or can I just multiply by the square root of 2? Do you even know? You only have to multiply by the square root. So if I want to rationalize this, I only have to do this. So then that would give me in the numerator square root of 2. Square root of 2 times the square root of 2 is 2, times 2 is 4. So that's what it simplifies to. Okay? Because if it was a multiple choice question, your answer choice could be this, it could be this, or it could be that. You know, any of them. But. Are we okay with that? All right. So our final technique is to simplify a complex fraction. So Mr. Ackerman came to me and he said, because he has AB third period, he said, so I just decided, especially after we did this one, that I was just going to skip this one. I was like, you know what, I'm going to make them do it, because I know they should do it and not freak out over the fraction. But then after that, now that I think about it, can you simplify this fraction? I mean, you're capable of getting combining this, and you know what to do with fractions, right? We're not going to have to do it with limits, because here's the good news. We need to talk about this for some reasons, but it says this is a long, tedious amount of work, and we know that. And again, there are times where you may have to do it, but after we've mastered the derivative, which we have not even talked about yet, we will learn about L'Hopital's rule, and Mr. L'Hopital is going to save your life and make all that a whole lot easier, okay? So I will just save you from that other one, unless you just want to do it. Y'all just want to do it? No, we'll come back. If we have time, I'll do it for those that want. Whoever said yes. If you said yes, it's because you love math and you just want to do it. I get it. Okay, so let's look at the special case. So we have a special case, the function of the absolute value of x over x. It appears often on the AP exam, and one of the things that doesn't really show up very well on here, this is an open circle. It looks like this. You may need to add your open circles. I don't even know if you can tell what the lines are. Looks like that. That's what it looks like when you graph it, okay? Because it's undefined at 0, because again, you'd get the 0 over 0. You need to memorize the graph of this function. It's not that hard. That's it right there, okay? Pretty sure I probably made you look at something like this when we did parent functions at the very beginning of the year. Not that I actually expect you to remember, but we did it because the transformations are the same. That's what I wanted you to understand, that the transformations are the same no matter what. So when we look at this down here, you don't need to worry about all those words. But when you look at this down here, and you know that this is what your parent function looks like, what's the transformation that's happening here? What is, if I have x minus 5, what does that mean my graph is doing? Any graph. It's a horizontal shift, right? And am I going to the left or to the right? To the right, because x is a liar, right? So what your graph looks like, so let's just sketch the graph, because that's the easiest way for this to make sense to you. And so we'll make this would be like 5, okay? And we'll have 1 and negative 1. So instead of starting here at 0, 0, we went to the right 5, so it looks like this. That's all that's happening to that graph. So it's a very simple graph. We just move to the right 5. So by understanding that and understanding our transformations, then we can do this by visually instead of algebraically, and you have something to look at here. The limit as x approaches 5 from the left, what's that limit? What am I, when I approach, 5, I think I said negative 5. I don't know what I said. As I approach 5 from the left, when I'm approaching 5 from the left, what's my y value approaching? Negative 1 is my answer. And that's a weird one, too, because you're not really approaching because you're already there, but it is what it is, okay? You never actually get there because it's undefined. Ask me a question. You sure? Liar? He's lying to me, but okay. We good? What questions you got? Okay. So just for the interest of time, and because it's on this particular section, since this is multiple choice, even on multiple choice ones, though, I really kind of want you to do this. We're not going to write out the separate ones, because if we look at this, if I substitute in 0, that's going to give me 0 over 0, right? That one you can just tell by looking. So if we factor this, I get the limit as x approaches 0. In the numerator, what am I going to factor out? X squared. That leaves me with 5x squared plus 8. In the denominator, x squared leaves me with 3x squared minus 16. So can I reduce this? Yes. And then now evaluate that when x approaches 0, meaning I can just do that with direct substitution. That would zero both of these out, and I get 8 over negative 16. And what's my answer? Negative 1/2. You good with that? Okay. Now look at number 2. This piecewise function where this is what my graph looks like if x does not equal 2. If x does equal 2, then it's 1. So a question like that, what this is saying, now this graph is not a parabola, but so you don't have to worry about what it looks like. It would look something like this. This graph is going to look like this, except when x equals 2, I have this random point over here. That's what's happening. So when you're talking about the limit, because that's what this is asking me, the limit as we approach 2 from the left and the right, this is the part I'm going to use because I don't really care what's happening at 2. You with me on that? I don't care what's happening at 2. We care what's happening approaching 2. So that means I really want, all these ask about the limit. I need the limit as x approaches 2 of this, which would you say that's going to give you 0 over 0? And if you can tell by looking that it's going to give you 0 over 0 as x approaches 2, which it will, then you can just start out by factoring. The limit as x approaches 2 of, what does the numerator factor into? Good. X plus 2, x minus 2, or vice versa, whichever one. All over x minus 2. All right, so those cancel out. Now, let's read our answer choices. It says the limit as x approaches 2 of f of x does not exist. And I want to know which one is true. Is that true? Does the limit exist? Sure does. That's not it. And then the rest of them say, what are the limit? Well, the limit as x approaches 2, what is it? 4. Okay. We okay with all that? Any questions at all? Ask me a question, Alex. Well, I know you're trying. You're not confused. You don't even know what to ask. You're just thinking. Okay. Well, if you come up with something, let me know. You too. You got it. You're just thinking. That's going to be the new words, right?